doing today's LeetCode daily challenge question. So the question is Stone Game 9. So let's understand the question. We are given this. Okay, Alice and Bob continue their game with stones. So we have recently 2-3 days back we have solved the stone game 6 problem. So you can solve that and come here as well. There is a row of n stones. Each stone has associated value. You are given an integer array stones where stones of I is the value of ith stone. So we are given a this is the stone array and the value of zeroth stone, that means index zeroth or first stone is 2 and value of second stone is 1. Now what we have to do is Alice and Bob take turns with Alice starting first. On each turn the player may remove any stone from the stones, and the player who removes a stone loses it if the sum of values of all removed stone is divisible by 3, and Bob will win automatically if there is nothing remaining stone, even if it is Alice turns. Okay, now what is the question? We are given what? Stones array. We are given a stones and its values. So it will be considering values v2, v3. What we have to do? We have Alice and Bob. We have to return true if Alice is winning and else false if Bob is winning. Now, what we are asked, see, so when Alice, each one will remove a stone from this stones array. Now, while removing, we have to check what? We have to check the sum divided by 3. If it is giving a whole number, okay, or you can say divisible by 3, then whoever's the turn was, that person will lose. Okay, so what we have to do to make Alice win, we have to select such number in the stones which will not make the sum divisible by 3. And also in the question it is given Bob will also play optimally. Now let's take the example and understand it more. Like 2 1, we'll take this example 5 1 to 4 3. 5 1 2 and 4 3. Now first is always Alice turn. Alice will take, let's say, 5. Now this was Alice turn. The sum is 5, so it is not divisible by 3. Now next Bob's turn. If I take 1, okay, Bob is also playing optimally. So if it takes 1, it will make the sum as 6. But 6 is divisible by 3, then Bob will lose. So Bob will not choose the 1. Let's consider Bob will choose the 2. So if Bob is choosing 2, what will be my son's sum is 7 now. Now it's Alice turn. If Alice will choose the 1, will it make divisible by 3? No. So it will choose the 1. Okay. Now my son sum is 8. Now we are done with 5 1 2. Next is Bob's turn. If Bob uh, chooses 4, it will be 12. 12 will be divisible by 3. So Bob will not choose it. Bob is also playing optimally. So it will choose the 3. That is 8 plus 3 is 11. It is 11, it will choose the 3. Now Alice turns. If Alice has 4, so if it has only one option to select it as 4. So if I add the 4, it is making the 15, and 15 is divisible by 3. So we can say Alice is losing. So Alice will lose this game, and that's why in the here output, if you see, it is returning the false. For the stones of 2, my 2 is what? True. If Alice is taking the 2, which is of course not divisible by 3, but since all the stones are removed and the sum of value is not divisible by 3, Bob wins the game. Yes, it is written here. Bob will win automatically if there are no remaining stone, even if it is a Alice turn. Now, for the stones, this 2 and 1, why 2? Consider my what? Alice is choosing 2. Okay, the Bob has to choose the another one, which is 1. Anyway, it will make the sum as 3, which is divisible by 3. So Alice will win, Bob will lose. That's why it is returning true. Now how we are going to solve? Okay, so first what we are going to understand, we have these values, okay, and we are given this 3. So if we are dividing this, so instead of that, can we convert this problem like little simpler? Instead of having this all numbers, Can we convert this into 0, 1, 2? Why 0, 1, 2? First understand that. Why? Because if I take the percent, okay, percent, or you can consider what will be the remainder values. If there is any value and if we are dividing it by 3, if it is not divisible, what will be the remainder? It will be 1 and 2. And if it is divisible, it will be 0. So only we can convert this set of data in the form of 0, 1, 2. Then it will be easy for us to solve this question. Now, can we convert this? Yes. So if I divide 5 by 3, what is the remainder? Remainder will be 2. Now, if I divide 1 by 3, it will be 1 itself. If I divide, this will be 2 itself. Now, 4 as 1 and this will be 0. Okay, now we have what? 2, 1, 2, 1, 0. The same thing. Okay, let's do it again. Alice will choose 2. And then Bob has to choose what? Bob has to choose this. Alice has already removed. If Bob selects the 1, it will make the sum as 3. Then it will not choose this. So it can choose what? 2. Now it's Alice turns. Alice, now the sum is 4. And if Alice chooses 5, that is fine. This is also done, right? Now it will choose the 1, which makes the sum as 5, which is not divisible by 3. Now Bob has to choose from 1 and 0. My sum is 5, and if I choose 1, definitely it is going to be 6 and it will divide by 3, and Bob will lose. But Bob is also playing optimally, so it will select the 0. And then Alice turn. Alice has to select one, and this way Alice will lose. So it's the same problem. If you see 5, first it has chosen 2, then second this part, and then 1 this part it has chosen. Then for B it has chosen the last element as the same as 0. So definitely we can convert this into this problem. Okay, so first step what we did is converted into 0, 1, 2. So now our problem is little simple. We are dealing with only these three values. Okay, now how these three values will affect. Okay, consider what is 0. So here if you have seen, we are asking Bob to choose 0. What is 0? Like if he chooses 0, he can avoid losing. Okay, avoid losing. So if there are two zeros in my array, let's say I have two zeros in my array, also Alice can use the same 0. Again Bob has to choose one, Bob will lose, right? So if I have even number of zeros, that, like, we can ignore it directly. Why? Because Bob and Alice are playing optimally and both can use it, so we can consider both will cancel out each other. If Bob is using 0, Alice can use the 0 and avoid that. Okay, now this is done. Now we can divide this problem into two. How? If my number of zeros, okay, if it is even and if it is odd, then we can divide it. Okay, if it is even, we are only focusing on number of ones and twos. And if it is odd, if there are odd number of zeros, each will cancel with another, there will be one last remaining. And in this example, who took the advantage before? Bob took the advantage of using that 0. Okay, and Alice has to lose. Okay, so for odd, we have to think what we can do. Now let's focus on the even first. If I have even, it will cancel out. Then we are just focusing on number of ones and twos. Now, if I have, let's say, if I have this example 1 and 2, okay, I have only this. Alice can choose any one. Bob will lose anyway. Okay, because we have only 1 and 2. There is no other number. If Alice chooses 2, Bob has to choose 1. Okay. Now if I have, let's say, 1, 1 and 2. If Alice chooses 1, Bob has to choose what? Bob has to choose 1 only. If he try to choose the second, then what happens is it will be 3. Now next is what? Alice has to choose 2. Okay, then it will not lose anyway. But what will be my sum now? 1 plus 1 plus 2. Okay, but in the question what is given, if Bob will win automatically if there are no remaining stone, if it is even if it is Alice turns. Okay, so in this case who are going to win is Bob. Okay, now if this is not the case, okay, in this case, now let's say Alice will choose the 2 initially. Now what Bob has to choose? Bob has to choose one only. Why? Because there is no other option. You have only two ones. It has to choose one of this. So it will choose the one and it will make, and in this case Alice will win. Okay, and in the question it is given that there is we have to, on each Alice will start first, right? Now we have to make Alice win. So what I'll do, we have two option. Alice has the choice, it can lose also, it can win also, so I will consider this, so that Alice can win. So in this case it will be true for this, even if this is the case. So if we see, Alice has the choice, so whatever Alice will choose, it doesn't matter now, because we will make it like if Alice is choosing two, it has to the Bob has to choose the one only, if this is the case. Okay, if there are more one and twos, okay, if there are more one and twos, let's say there was one more two. Okay, if there was more to here also, Bob has to choose again two, which would have made the sum as 6. The Bob will lose, and here Alice will lose in this case. So if you see, Alice had choice. So every time Alice had choice, Alice will win. Where when we have even. So if I consider the count of ones, if they are greater than 0, and count of twos, if they are greater than 0, we can say Alice will win. Why? Because Alice had choice. Just now we have seen the same example where Alice can lose also and also can win. Okay, but Alice has choice, it can choose the second also to remove. So this is done for even. That's how. But for odd, it's not the case, because it Bob has advantage. Here instead of choosing was, Bob can choose one 0 also, right? And then what option Alice has? Alice has to choose one. Right. So in that case, if you observe this question itself, if I have, if number of ones and twos, if there is difference, a lot of difference, that Alice can again make a choice and win the same way. Okay. If I have, let's say three twos I have and three ones I have, and here I have option, even if Bob uses that 0, if the at Alice what uses one or two multiple times without making the divisible, Alice can win. So that's it for odd. Even if it is little confusing, but if you take the example of multiple, and here there are, we have multiples, right? If even if the Bob take the advantage, but after a point of time, after let's say minimum is 3, if we want the 3 one, if I have the 3 extra ones, then what I can do is Alice can choose the one and make it like, just try to avoid losing. Okay, try to avoid losing by making this as negligible. Okay, so in that case what you will do is count of ones minus count of twos if it is greater than 2. Why greater than 2? If 1 is there, Alice can't win. In this example only we have seen, if 2 are there, still Alice can't win. Okay, because if there are difference is 2, I'm talking about the difference, not the just the number. Okay, here in this case the difference is just 1. If there are 2, then we would have got this 2 multiple times. Okay, let's say I have 3 ones and 1 2. Alice is using 2 and 1 0. Then in that case also Alice will win because we have 0. But if I have what let's take, I have 4 or 1 1, and I have 4 twos. So in that case I can make use of 2 again and try to avoid the losing situation in this. So here we have to take just the absolute take, any one is okay. And then if it is greater than 2, then only it will win, otherwise it will lose. And that's it. Now let's start implementing. First we have to count the number of zeros. So what we will do is int a, let's say this is count for 0, count for 1, count for 2. For int I is equal to 0, I less than stones dot length I plus plus. If a, before that we'll find the mod. Mod will be what? Stones of I percent 3. If mod is equal to 0, then we will increment a plus plus. Else if mod is equal to 1, we will increment the b, and else we will increment the c. Anyway, it will be just mod equal to 2. Now we have the count. And what we are doing, if my a is even, a percent 2 is equal to 0, that means it is even, then we just have to return what? True if both are greater than 0. B is greater than 0 and C is greater than 0. Please rewatch it if you are getting confused again, because I have explained properly. Now return if it is odd. What you have to return? Mat dot absolute value of B minus C, which is greater than 2. Then only you have to return true. Else false. Why? Because one will make lose if Bob is taking the advantage. Then minimum 3 we want. Okay. Let's see this. I have 1. Output is true, expected is false. I have this. Oh, C, mistake. C should. How come this? I don't know. How come this test case got passed? C should be 0. I initialized it incorrectly actually. Maybe in those example there was no with 2. Okay, you can see the solution is accepted. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.